In the given figure, O is the center of the circle of two concentric circles of radii 5 and 3. So we mark this. So this is 5 here, 5 centimeters, and this is another one here. This is given as 3. From an external point, P tangents PA and PB are drawn to the circles. If PA is 12, then find PB. So let's take up now. So we'll mark PA as 12. This is given as 12. We'll just draw this 12. Now here we have, this is radius, this is tangent. So this angle is 90, and we're going to use Pythagoras theorem in this triangle. In this blue triangle, we're going to use the Pythagoras theorem in this one. So you have seen here, this is 90 degrees. So we'll use the hypotenuse will be OP. So let's start. Now we have triangle OAP. So OP square, which is a hypotenuse, equal to OA square plus AP square. Put the values. OP we do not know. See, this is question. We do not know this part. This is question. We do not know it. So OA is 5 square, and this is 12 square. So OP square equal to 25 plus 144. Your OP will work out to be 13. So your OP is 13. So let's mark that. So this is now, we know this is 13. We'll get up into the next figure just to make it neater. So here we are going to now tackle this triangle. This triangle. And in this triangle, let's write down what we know. We already know this is given as 3. We found out this is 13. So this is our question now, PB. We know this angle is 90 because the angle between the radius, this is the radius, and the tangent is always 90. So let's use now Pythagoras theorem in triangle OPB. Remember, we do not, this is the hypotenuse. In this case, this is hypotenuse. So we have OP square equal to OB square plus PB square. So 13 square will be equal to OB square is 3 square plus PB square. So 169 equal to 9 plus PB square. So I get on here, PB square will be 169 minus 9, PB square will be 160, and your PB will be under root of 160. When you simplify, you get 4 under root 10. So your TP equal to 8, and that's done. In the figure, a circle touches the sides DF of triangle EDF at H and touches ED, EF produced at K and M respectively. Now here they have given EK is 9. Let's mark that up. This is the EK. EK is 9. This whole thing is 9. Now if this is 9, I'm sure you'll agree this also is 9. Tangents from an external point are equal. So we have EK equal to EM equal to 9. Now here again, if I take this as an external point, and I will now have this is equal to this, and I will take it as x. This is x, and I will take this also as x. So I have here dH equal to dk, which is equal to x. Now let's take a look at EK. EK is 9, and if you look at EK is made up of ED plus x equal to 9. So my ED becomes 9 minus x, this part. This part ED is 9 minus x. Now on the other side again, I have an external point here, f, and from f I can draw two tangents, that is fh and fm. So we will do that. fh equal to fm, say equal to y, the reason tangents. So I'll put this as y and I'll put this as y. Now look at what should EF be. EF will be 9 minus y, because we know that EM equal to 9, and EM is made up of EF plus FM equal to 9. Now FM we take as y, so EF plus equal to 9. So our EF will be 9 minus y. So we are interested in this perimeter of this triangle. Now let's mark the parts of this perimeter of this triangle. We saw that ED was 9 minus x. This EF we have taken as 9 minus y. This was x and this was y. So in triangle EDF, it has got three sides. One is ED, one is EF, and other one is DF. And what are the sides? EF is 9, ED is 9 minus x here, because this was x, this whole thing was 9, this was x. Now EF is 9 minus y, and DF is x plus y. So the perimeter, if we add up now, ED plus EF plus DF, let's put the values. 9 minus x, 9 minus y, plus x plus y. Now here, minus x plus x, this will cancel out, and your answer will work out 9 plus 9, and that is 18. So the perimeter of DEF is equal to 18 centimeters. Now the sum is quite a simple one. So we have here as QP is 4.5. So let's mark that. I'll mark it here. This QP, I'll mark it, I think QP here is 4.5. So QP equal to PT. Why? Tangents from an external point are equal. This is your external point. So if this is 4.5, this also becomes 4.5. Now on the other side, if we take this as external point, here I take an external point, I can say PT equal to PR. So if this is 4.5, I will say this also is 4.5. So their total QR becomes 4.5 plus 4.5. Let me write it out. So first we have PQ equal to PT, which is 4.5. Reason tangents from an external point. On the other side, I have PT equal to PR, which is also again 4.5. Tangents from an external point are equal. Now when I take up QR, my QR equal to QP plus PR. That means it is 4.5 plus 4.5, and the answer is 9. Have you seen 4.5 till here, 4.5 till here? So it will be 9. These tangents from external point are equal, and this also is equal to this. If the radii of two concentric circles are 4 and 5, then the length of the chord of one circle which is a tangent to the other. So here we have two concentric circles. What do you mean by concentric circles? Which have the same center. One radius is given as 4, like here, see, this is the radius is given as 4, and this radius is given as 5. We need to find the length of the chord of one circle which is tangent to the other. So here, this is AB. Look at AB. AB is chord to large circle, but AB is also tangent to small circle. And we need to find this AB. To find this AB, we'll first focus on this triangle. In this triangle, we know this is 90 degrees. Why? Because we have OC is the radius and this is the tangent. So let's start from there. So in triangle OCA, we use Pythagoras theorem. First we know angle OCA equal to 90 because radius perpendicular to tangent. Then using Pythagoras theorem, we have OA square equal to OC square plus AC square, means 5 square equal to 4 square plus AC square. So 25 equal to 16 plus AC square. You have 25 minus 16 equal to AC square, and your AC becomes equal to 9. Now we have to find AB. I'll just draw the figure here like this. This is the smaller, and here, right? This is your AB. This is your AC. You have already shown that this is, by the way, this is AC square is 9, so your AC will become 3. Now we have already shown AC is 3. This is also 3. Why? We have that property. A perpendicular from the center bisects the chord. Remember the property, perpendicular from the center bisects the chord. So your AB equal to 3 plus 3, and that is 6. Now for this, it's given as, in the given figure, O is the center of the circle, AOC is a diameter. Now let's mark AOC as a diameter. Now remember, if AOC is a diameter, that means this angle will be 90. We learned it last year. If AC is diameter, then we can say angle B equal to 90. The reason, the diameter subtends 90 at the circle. Now the next thing we are going to do is we are going to take this triangle and we are going to use angle sum property. We will put this as X here. So in triangle ABC, we'll use the angle sum properties. 3 angles, angle 1 plus angle 2 plus angle 3 equal to 180. One angle is 50. This angle we have already shown is 90. So this is 90 here. And the third angle, that is X, we don't know. So we have 140 plus X equal to 180. So your X becomes 40. Now for the third part. So we know our X here now is 40. Now this angle will be 90. Why will it be 90? This is radius and this is tangent. So this angle, full angle, is 90. Let's put this part as Y. So if you look at angle CAT equal to 90, and CAT is equal to Y plus 40 is equal to 90. So your Y is 50. In the given figure, a circle touches all 4 sides of the quadrilateral PQRS. So here is your circle, and it touches the sides of the quadrilateral. This is your quadrilateral PQRS. And you have done this proof. If this is the case, you have already proved it in your NCRT. You have proved that the opposite sides, means PQ, this is PQ here, plus SR will be equal to the sum of the other 2 opposite sides, that is PS plus RQ, and that is PS plus RQ. That property we must remember, and you have proved it in the NCRT. Now we'll put the values. We know our PQ is 6.5. Our RS we need to find out. equal to our PS here is 4.2 and your RQ is 7.3. And on working this out, you will get your RS equal to 4.2 plus 7 by 3 minus 6.5, and your RS will turn to be 5 centimeters. In the given quadrilateral ABCD is circumscribed touching the circles at P, Q, R and S such that DAB is 90. Let's mark that, this is 90. CR is 23, CB is 39 and the radius is 14. Find the measure of AB. Here when we use the property points, so here an external point, so and in this case we know PB equal to PS. Let us mark all that first. Here in external point, so we know here 2, this is equal to this, and then this is another external point, so this are equal. This is equal to this external point. Fine. Now let's get on. Now first we know this is 90. This angle is already given just to right. This is also 90. Radius tangent. This is also 90. Right? So this also will be 90. So this inner figure now becomes, this figure here becomes a square. This now becomes a square. If this is a square, I can say this is 14, this also will be 14. So that is the first step. So we have quadrilateral POQA is a square, and because it is a square, I can say OQ equal to AP equal to 14. Now let's get on from this side. We know that CR is 23 and therefore this also will be 20. Let's repeat that. We know that CR is 23, so your CS will also be 23. So we write that out. CR equal to CS, which is equal to 23. Now here it is given to us that BC equal to 39. So your BS will be 39 minus 23. See, this entire thing is given as 39. This whole thing is given as 39. This is already 23. So the yellow will be 39 minus 23. And that works to be 16. So this is 16 now. This is 16. If BS is 16, BP will also be 16. So if BS is equal to BP, tangents from an external point, so that is 16. Okay, let me just make this point again. How did we get BS is 16? Is because BS was 39 minus 23 and that became 16. Now we need to find the entire, we need to find this entire AB. So our AB, if you look up in the figure, is 14 plus 16 and that is 30. So your AB is 30.